Okay, so what I'm going to do in this video is show you how to use your TI-84 graphing calculator to find the confidence interval for the population proportion. So remember, a confidence interval is an estimate of a parameter that you're looking for. And in this section, remember, we're studying the population proportion, which remember is a number that represents the percentage or proportion of people that agree with some question at hand. The example that we're going to look at right now is when it's in our notes in Blackboard, and this is the Biff Bullshooter question. So let's give this a look. So it says, what percent of Nassau County residents are going to vote for Biff Bullshooter in the upcoming election? Assume that in an unbiased survey of 600 Nassau residents, so there's a sample right there, 600, 317 said, yep, I'm going to vote for Biff. All right, so in other words, we can't ask everyone in Nassau, obviously, but we'd really like to know what that number is. What percent of all of Nassau County is going to vote for Biff? And we're going to use this information here, the fact that 317 said, yeah, I'm going to vote for Biff out of the 600 people that I asked in my sample. These two numbers here are going to help us create a statistic, and we're going to use that statistic to create the confidence interval. All right, so it says letter A, what is the value of the sample proportion? All right, so the sample proportion, remember, is called p hat. And by definition, p hat is defined to be x divided by n. So, the answer's here. I'm sure you've seen the answer already. So what we're going to do really is talk about this and how to, crunch it on your calculator. But the definition of p hat is x divided by n, where x is the number of people that said yes to the question. So the question here would be, hey, you're going to vote for Biff? Yes or no? And out of the 600 people they asked, 317 said, yes, I'm going to vote for Biff. So the percentage here, as a proportion or a fraction, it's 317, which is the x, and then 600, which is the n. That's just a fraction. Fractions are decimals, and decimals can be converted to percents. So when you divide that in your calculator, you get approximately 0.5283, and you can see that here. 317 divided by 600. You hit enter. So there it is, and I just rounded the 4 decimal places, as you can see. Take that decimal and move it 2 spots to the right, which is the equivalent of taking your calculator, multiplying by 100. This will express this as a percentage. So that's about 52.8, or call it about 53% of the people that we surveyed here out of the 600 people. About 53% of them said, yep, I'm going to vote for Biff. All right, so again, this tells us about 52.83% of the persons in the sample said they're going to vote for Biff. Obviously, the sample, knowing what it is in the sample is great, but we really want to know what it is for the whole population of Nassau County. We can't ask everyone in Nassau County, if you're going to vote for this guy or not. So obviously, this is why sampling is a necessity. So it says we're going to use this value to estimate the value for the population proportion P. Okay, great. I put as a little note here, also note that Q hat, which those are the people that, the proportion of people that are not going to vote for Biff. In other words, ones that said no. So obviously, if about 53% said, yeah, I'm going to vote for Biff, and as you can see here, 1, which is 100%, subtract off 0.5283, or about the 53%, that's about 47%, as you can see. So 47% of our sample said, nope, I'm not voting for Biff. All right, so the question didn't ask me for Q hat, but we're going to use Q hat in a calculation of the error. So figured, that's why I calculated it here. Letter B says, construct a 95% confidence interval for the proportion of Nassau residents that are going to vote for Biff. All right, so in other words, this, 52.83% that we got for our estimate for our sample, the P hat, really we want to know what the P is. The P stands for the population proportion. So we'd like to know what that percentage is for everyone. All right, well, obviously, using this as an estimate, we know it's going to be off a little bit. So that's why I went through here. I showed you how to calculate the error. The error, as you can see, is about 4%. And then we took that 4% and we added it and subtracted it to the p hat. That's what happened down here. You add and subtract the error to the p hat, creating this confidence interval estimate. Okay, this is great, and doing it by hand is great, and understanding what it's saying. But your TI graphing calculator will crunch this thing for you literally in seconds. So remember where the confidence interval menus are. It's in the testing menu, which is located under stat. So if you push the stat button and then move over to tests, in a couple of earlier videos, I showed you how to use options 7 and 8, which those were confidence intervals for the population mean using the normal distribution and the t-distribution. down a little bit further is the confidence interval for proportions, and you can see it here. It says prop meaning proportions, that's P. So 1 prop Z int. You see they're abbreviating the word interval right here. These are all confidence intervals. Now we're not going to learn these 2 sample confidence intervals. The 2 sample confidence intervals you learn in a statistics 2 class, which is Math 103, here at our college. We're just going to worry about the 1 sample stuff. So option 7 and 8, which are for averages, and option A here, which is 1 prop Z int. All right, so if I select that option, so notice it's being highlighted right now. I used my cursors and highlighted it. Hit enter. And it's pretty straightforward. There's not much to give it because there's not much involved in the question. There's how many people said yes, how many people did you ask, and what do you want your confidence level to be? So remember, this menu, what it's going to do is it's going to crunch this error formula, simultaneously take that error and add and subtract it to the p-hat and give you this confidence interval. I believe it gives it as a decimal, so we'll see that when we do it. So the x was 317. The n, the number of people, which is the sample size that were polled, was 600. And this question here says 95% confidence interval. All right, so I'm going to leave that as 95%. Go on top of calculate, let it do its thing, and there you have it. So there's your confidence interval, the lower limit of confidence and the upper limit of confidence, which is the same answer that we got here when we did it by hand, 0.4884. As you can see, 0.48839. The calculator uses more decimal points. It's not rounding this p-hat. Like I rounded the p-hat in the calculation here. The calculator doesn't have to because, it could keep up to 10 decimal places. All right, so there's the low and upper confidence limits. So it's the same numbers as here. And then, of course, you round these to whatever you want to round to. But, traditionally, you usually keep 3 decimals, which is a fine estimate. Notice, by the way, when you use the calculator, it does not give you the error. Now, we calculated the error and got 0.0399. So remember, to get the error of any confidence interval, you could take the upper limit and the lower limit. In other words, find how far apart these 2 things are. Because remember, those 2 things, they were created by taking the p-hat and adding the error to create the number on the right, the upper confidence limit, and subtracting the error to create the number on the left, which is called the lower confidence limit. So the distance between those confidence limits, the lower and upper limits, is actually twice as big as the error. So if you go over here and type the higher limit, 0.56828, and subtract off 0.48839, close those parentheses and chop it in half. Notice that 0.0399 number, and that's a little more accurate, obviously, and we discussed this because the calculator's answers are a little more accurate, but notice that's the same answer as we got here. Let's just face it, this is about 4%. So, about 53% of people said, hey, I'm going to vote for Biff, give or take 4%. That's exactly what this confidence interval is saying. This 48.84%, that's about 49%. This is about 57%, right? So that's the 53% give or take 4% is what essentially that's saying. All right, so remember, in the calculator, if you're asked for the error for whatever reason and you use your calculator, the calculator doesn't hand you the error. You kind of have to back into it. Take the confidence limits, subtract them, make sure you use parentheses, cut it in half. You'll always get the error there. And that goes for any of the confidence intervals that we've learned. All right, so let's look at the rest of these questions because there's not much to go on here. So letter C says, interpret this confidence interval verbally. All right, well, the standard textbook way to say this is that we're whatever percent confident that the population proportion is going to land somewhere between these numbers. That's what essentially it says. We are 95% confident that the population proportion of Nassau residents who are going to vote for Biff in this upcoming election lies between, and I wrote it as percentages. I prefer to see it as percentages. In my math lab, just be careful. My math lab, sometimes they leave it as decimals, sometimes they convert to percents. You just got to pay attention to the directions and, of course, always pay attention to the rounding in my math lab. It's kind of a standard textbook way to say the interpretation verbally. All right, and then finally it asks, is it reasonable to say that 60% of Nassau residents are going to vote for Biff? And then explain. Well, remember, our estimate was about 53%. So 60, some people might argue, yeah, it's close. But you know what? You don't worry about saying close here. We got a confidence interval. There's the confidence interval. 60% doesn't lie inside that 95% confidence interval. So 60% over here to the right somewhere. So if we say we're 95% confident, really it's 95% of all samples of size 600 are going to produce a percentage that lands inside here. There's so many ways to talk about this confidence interval, and people argue all the time the correct way to say it. But there are other ways that I think are more appropriate than what we're listing in C here. But this is kind of a standard that you'll see everywhere you look. But 60%, it's not a reasonable value because it doesn't land inside of our 95% confidence interval. If they gave us a number like 55%, then I'd say, yeah, that seems reasonable to me because it lands within my confidence interval. Pretty standard calculation. The calculation by hand isn't terrible, but obviously the calculation on your calculator are a lot easier. So remember how you get there. Stat, move over to tests, scroll down to option 0, I believe it was. Nope, it was option A, 1 prop z interval. Enter the information, then tell it to calculate. And you get that answer right away. By the way, notice that it also tells us the p-hat, which is kind of interesting too. I think that's mainly used for a check, or it's mainly used also because you could also take the upper limit and subtract off that estimate. So take the upper limit and subtract off the p-hat. That'll get you the error as well. Instead of just subtracting the upper and lower limits and cutting it in half, find the distance from the center essentially, which is p-hat, to either the lower or upper limit, and you'll also get the error. All right, so if you have any questions, shoot me an email. Thanks for watching.